Hello everyone, this video covers the lecture notes for week 11. The topic is zeros of polynomials. We talked about zeros of polynomials before, and we've been talking about polynomials for the last few weeks. Now, just to refresh your memory, when we say zeros of polynomials, it means this, where it crosses the x-axis. So zeros of polynomials is the same thing as the x-intercepts. Okay? So this is not new. You have found the x-intercepts or zeros of polynomials before by factoring mostly. The difference is that now we're going to be more specific. We're going to go into a lot more details about these specific points. And there is something called multiplicity, and we'll get to that in a little bit. And the last thing that you need to know how to do, and you'll probably have one of these questions on the test and in the quiz, is if they give you the zeros of a polynomial. So if I give you these 3 points and another point, you should be able to figure out the formula for the polynomial. So that's all we're going to do. So let's start with multiplicity and how it does affect the shape of the graph near the 0 or the x-intercept. Here we have the function f of x, and this is the actual graph of the function. Okay, so you can see that this one has 3 zeros, one in -2, one in 2, and the other one in 4. Also notice the end behavior of this. As x goes to infinity, this goes to infinity, and as x goes to minus infinity, this also goes to infinity. So therefore that means that this must be a even polynomial, and you can see that by adding the exponents. 2 plus 3 is 5 plus 1 is 6. So therefore the degree of this polynomial is equals to 6. Now you should make a note of this. This is very, very important. It's actually called the fundamental theorem of algebra. And what that means is that you have at the most and the most 6 zeros. Okay, as you can see, this one only has actually 3, and that's where the multiplicity comes in. If the degree is 6, it means it has the potential of crossing the x-axis 6 times. It doesn't mean it will, but it cannot cross it more than 6 times. That's what the fundamental theorem of algebra says. Okay. And if it doesn't cross 6 times, then it is because of something called multiplicity. If the graph is given, like this is the case, the multiplicity is pretty easy to see. The multiplicity of -2 is 2. The multiplicity of 2 is 3. And the multiplicity of 4 is 1. The tricky part is when they don't give you the actual equation and you have to look it from the actual graph. Still, it's not that hard, but that's the idea. All right, so let's analyze this graph more. And this says the following: the 0 of x equals to -2, which is this one. You can see this is a kind of a parabola, has multiplicity 2, like I just told you, because that's the exponent right there, which is even. Okay. And near the 0x equals to -2, the graph of x squared, and I just told you this now, the graph of this function is very similar to the monomial just x squared. Now the 0x equals to 2, you look closely, this is like a cubic equation. So therefore this one has multiplicity 3, Why? Because you can see that the exponent for this one is 3, and I told you that already. This one is add and greater than 1, because the multiplicity is 3. Okay. Now near the 0 at x equals to 2, the graph looks like the transformation of the graph of the monomial minus x cubed. Remember that x cubed looks like this, but minus x cubed, it will look like this. So it will be x cubed minus x cubed. Now the 0 of x equals to 4, which is this one right here, has multiplicity 1. So it's odd and equals to 1. So notice that the only choices you have is either even, odd and equals to 1, or odd and greater than 1. Okay? And this is like the monomial just x. Alright, so now let's look to an example where they just give you the graph and you need to analyze the multiplicities. Before we do anything, you look to this graph. Notice that this keeps going this way and this goes this way. So technically the graph looks like this. So this one has to be x to an odd power. So we talked about that last class. Okay? First, you need to identify the zeros. So the zeros are -4, -3, -1, and 3. Those are the zeros. So potentially, that means that f of x has to be equals to x plus 4 times x plus 3 times x plus 1 and x minus 3. Okay? And then the exponent for this one is going to be add. For this one, it has to be add. X to the -1 is also add, and x cubed it will be even. And if you add an odd number plus an odd number, you get an even number, plus an odd you get odd, plus even you get odd, which is what you're supposed to get. Now I already talked about this part, is the degree of the polynomial odd or even. I mentioned that in this part. We already said it has to be odd, and you can see that from the shape, because this way goes down, this goes up. If it was even, remember, to be even, it would have to look like this, or we have to look like this. So clearly this is odd. So now let's see the values. So the zeros we say was 4. So they should be 4. Sorry, -4, -3, -1, and 3. Alright, so -4, as you can see from here, is add and equals to 1. So that will be the multiplicity, add and equals to 1. -3 is add and greater than 1, which it could be 3, 5, 7, and so forth. Okay? So this means 3, 5, 7, and so forth. -1 is also add and also greater than 1. So again, 3, 5, 7, so forth. And 3 is even, so you can see from there. Now, what is the end behavior, which is what we did in the last section? So you can see that y goes to infinity as x goes to infinity, and y goes to minus infinity as x goes to minus infinity, which is exactly what we did before. Now from the end behavior, we know that the degree of the polynomial is odd, which I mentioned that at the beginning, and the leading coefficient is positive. Remember, if it is odd and the leading coefficient is positive, it will look like this. So it will be for leading coefficient positive, and the graph will look like this if the leading coefficient was negative. Again, that's just a review of what we did last time. The last thing we will talk about is called the factor theorem, and as the name says on it, we're going to need some factoring. Before I go to the official definition, which is this, let me explain this with an example because this is very, very simple. You actually have done this already. Let's say the p of x is equals to x squared minus x minus 12. Okay? Obviously, you can factor this as x minus 4 times x plus 3. So therefore, this one has two factors. The factors are x minus 4 and x plus 3. Obviously, if you put 4 here, the whole thing will give you 0. And also, if you pick minus 3, the whole thing will give you 0. So now this is just a new way to redefine the stuff you already know. So clearly, p of 4 will be 0. Why? Because 4 minus 4 is 0. And then p of minus 3 will also be 0. Why? Because these are the roots or the zeros of the equation, and these are also the x-intercepts. Exactly the same thing we talked about before. So what the factor theorem actually says is the following, is that if p of 4 is equals to 0, that means that x minus 4 is a factor of this. It also means that if p of minus 3 is equals to 0, that x plus 3 is a factor. So this can be very useful to factor polynomials that they may be a little tricky to factor. Okay, so now let's go to the official definition, which you understood what I just say here is exactly the same. And it says the following. The input x equals to z, which in our case, you could say 4 or negative 3, is a 0 of the polynomial if and only if x minus c, which in our case could be x minus 4 or x plus 3, is a factor of p of x. Again, it's exactly what I just explained here. So therefore, the vocabulary is this. When x equals to c is a 0 of p of x, we know the p of c will be 0. And when x minus c is a factor of p of x, we also know that p of c is equals to 0. Again, just refer back to this. Now here, in this example, you have the function g of x, which is already factors. We already have two factors. So it's asking you to find the zeros. So the 0 of this one will be x equals to 5. And the 0 of this one will be x equals to minus 2 over 3. So those are the zeros. So according to the factor theorem, well, you could rewrite this as x minus 2/3 and x minus 5 will be the factors. So how do you rewrite g of x in terms of these factors? Then, well, g of x will be the same thing as x minus 2/3 times x minus 5. And that's it. All right, the next example says find 3 different polynomials with degree 3 and zeros of x equals to 0 and x equals to 5. So the first one could be something like this. X squared times x minus 5. So this one is a third degree polynomial, because if you distribute, this will be x cubed minus 5x squared, but it has 2 zeros at x equals to 0 and 1 at x equals to 5. Or let's say you can have p of 2. The 2 just means second example. And you could have x times x minus 5 squared. This should be 2, not 3 different ones. Now finally, this is probably the hardest question because you had to incorporate the whole thing, the last two examples, sorry. But you kind of have done this before for quadratic equations, okay? So it's the same idea, and this is what I mean. It says find a formula. Let's say that the formula will be h of x for a polynomial of degree 3. So it's already telling you the degree whose the graph is given. Notice that you have a 0 there and a 0 there. So therefore, here you will have x plus 4. Why? Because minus 4 is a 0. Remember, the multiplicity of this is 1. And then here you have x minus 1. And this has an even multiplicity, so that will be 2. So that's the polynomial. But you want it to pass specifically to the point 0, negative 12. So you need to have a constant in front. So times c. So this is a constant. And you need to find this one. Need to find. And once you find the value for c, you're done. And we're going to use this point to find the value. So the point 0 minus 12, remember this is the value for x, this is the value for y, or in this case, y is the same thing as h. Okay, so this is, we call it h, that will make it easier. So what this says is the following, that minus 12 is going to be equals to 0 plus 4 times 0 minus 1 squared times c. So remember, what you're trying to find is the constant c. So minus 12 is equals to 4 times 1 times c. So that means c is equals to minus 3. So therefore, the final answer is going to be this. This is equals to minus 3 times x plus 4 times x minus 1 squared. So you can put the constant in front. Now the last question, or the last example, is the same as this one, except that instead of a graph, give you the points. So it gives you the points right here. So here it says to find a formula for g of x. Remember, the hard part is to figure out the constant. This has to be degree 4, and the zeros are 1, 2, 3, and 4. So this will be x minus 1, x minus 2, x minus 3, x minus 4. And then it passes through this point, which this is equivalent to this. Without this point, you will not be able to figure out the value for c. So from here we have that 600 is equals to c times minus 2, minus 3, minus 4, minus 5. And then if you do the algebra, you have that 600 is equals to 120c. So that implies that c is equals to 5. So therefore the polynomial is going to be 5 times x minus 1, x minus 2, x minus 3, and x minus 4. And that's it. So you can see this is very, very, very simple. All right, so that's it for this week.